2015 Paper 1, Question 3, Integration. So in this question here, we're given the function minus x squared plus 12x minus 27, which we know is a quadratic, and we're asked to complete the table below by subbing in our values of 5, 6, 8, and 9. So that means we're going to take our function, f of x, and wherever there's an x, we're going to replace it with 5, 6, 8, and 9. So we're going to sub in 5, making sure we're using brackets. And then if I simplify that, that gives me minus 25 plus 60 minus 27, which is 8. So I'll put 8 into my table. And then I'm going to do the same for 6. So wherever there's an x, I'm putting 6. So that gives me minus 36 plus 72 minus 27. And therefore that's 9. So I'll put in 9 into my table. Do the same for 8. So wherever there's an x, I'm putting 8. And that gives me minus 64 plus 96 minus 27. And that's equal to 5. And then sub in 9. So we have minus 9 squared plus 12 times 9 minus 27 is equal to minus 81 plus 108 minus 27, which is 0. So now that we've done the table, we have to use the table and the trapezoidal rule to find the approximate area bounded by the graph and the x-axis. So what does that look like? Well, if we do a quick sketch of our graph, we can see it's an N-shaped quadratic. And if we go to page 12 of our maths tables, we have the trapezoidal rule, which basically is going to say to us that the area is approximately equal to, so always important to use approximately here, h over 2, which is the width of our trapezoids. And then we have the first height plus the last height plus twice the sum of the rest. So what is our first height? Well, our first height is 0. Our last height is equal to 0. And then the sum of the rest, well, they were our values from our table, which was 5. We had then 8, then we had 9, then we had 8, and then we had 5 again, and then we were back to 0. So if I put in my values, well, what's my width of my intervals? Well, I'm only going up in an interval of 1. So 3 to 4 is 1. So that's h. So therefore we have 1 over 2 times the first plus the last plus twice the sum of the rest. So 5 plus 8 plus 9 plus 8 plus 5. In other words, our area is approximately equal to a half times 2 times 35, which then gives us an area approximately equal to 35 square units. Okay, so we had 15 marks for part 1 and part 2, so filling in the table and getting our approximate area using the trapezoidal rule. So the marks were 0, 4, 7, 11, and 15. So in part B, then it wants us to integrate our function between the limits of 9 and 3. And if we go back to our graph there, we can see 9 and 3 is what we were sketching our graph within. So in other words, these are our limits. So the area enclosed with the function on the x-axis is between 9 and 3. So if I integrate minus x squared, I get minus x cubed over 3. If I integrate 12x, I get 12x squared over 2. And if I integrate minus 27, I get minus 27x. So subbing in my limits for 9 and 3. So that's going to be a minus 9 cubed over 3. Plus 12 divided by 2 there, I'll just simplify that to 6x squared. So that's going to be 6 times 9 squared minus 27 times 9. And then I need to subtract from my lower limit. So that's going to be minus 3 cubed over 3. 6 times 3 squared minus 27 times 3. So in other words, we have minus 243 plus 486 minus 243 minus 9 plus 54 minus 81. And then if I simplify all of that, we end up with 36 square units for our area enclosed. Sorry, we weren't asked for area there, so I really shouldn't have square units in my answer. It's more that the answer when I integrate my function between 9 and 3 is 36. It's more because I'm looking at part 2 here. It says use your answers above to find the percentage error in your approximation of the area corrected at 1 decimal place. And that's because when we integrate, we say i.e. the exact area is equal to our integral of f of x dx. So therefore I can compare for my percentage error. So my percentage error is going to be the actual area minus my approximate area over the actual area times 100. And therefore that gives me my percentage error is equal to 2.8%, making sure correct to 1 decimal place. So there was 10 marks going for those two parts. That was 0, 4, 8 and 10. And again, I'm going to star that because we had to write it correct to 1 decimal place. So if we hadn't got it correct to 1 decimal place, we would lose a mark.